Hi, yeah, so I'm coming back here. Yeah, PowerPoint crashed. Oh, I'm not bothered by it at all, am I? Oh well, we're filling out this truth table here, and we're looking for that circuit. You guys should have the circuit in front of you. Okay, and with 0, 0, the base was off because we had 0.7 volts at the base, and when either of those diodes was turned on, we had 0.7 volts at the base. The base was off, and therefore the output was 1 for all those cases. Okay, now when we turned off both of those diodes by applying high voltage to the N part of the diodes, the base was pulled up to VCC, and the base became on. And when the base is on, we were just calculating that it needed to overcome 3 PN junctions, but 5 volts is certainly higher than 0.7 plus 0.7 plus 0.7, 2.1 volts. And so if we properly size the resistors of that inverter, then we should put it in saturation, and the V out should go to logic 0. It will go to VSAT. Okay? All right, so recap. Okay, so recap. We had kind of something like looks like an AND gate here, all right, and something that looks like an inverter here, and we still really have not addressed as to why exactly we need that diode in the middle. All right, so the reason why we need to have this diode in the middle, and it's slightly a bit more of an advanced subject, is that you have to remember that 0 input can be as high as 1 volt, right? So we can look at this situation that we indeed have a high 0 here, 1 volt, and 1 volt here. And with this being 5 volts, we're still going to turn on both of these diodes, A and B, but now we're going to have the base voltage here of 1.7, right? Because it goes up now by 0.7 volts with respect to 1 volt. All right, so this is now base is 1.7 volts. Notice that if we didn't have this diode here, then 1.7 volts would have been enough to turn on the inverter, right? And we would actually have the output of 0, which is what we don't want, okay? The high zeros could result into a confusing output there, okay? So this diode there in the center is just to increase the threshold a little bit, right? Well, another way you guys could analyze it is figure out what happens for all the combinations of important voltages here for A and B. Those would be 0, 1, 3, 5, and so forth. Okay? All right, I guess that's the main thing that we need to discuss here. All right, so the next lecture would be on the simple TTL logic.